Welcome once again to everyone who made it to the last day of BioSolveIT's Drug Space Symposium. I can very well imagine that on a 4 p.m. on a Friday afternoon, you could be doing a lot of things, but you chose to be with us. And for that, I'm really thankful, especially to people in parts of the world who are crossing 7:30 or 8 p.m. By now. So thanks a lot, first off. All right, so I thought by concluding this 3-day event, we could start with a broader perspective on introducing our products and our tools and our mission and solutions to the general audience from a holistic point of view. Holistic/philosophical point of view, especially because we've seen a lot of the hardcore science, the application in the past few days. And if there's someone who's window shopping for our products or looking at afar, I hope by the end of these 30 minutes or so that you get a clearer, holistic bird's eye view of what BioSolveIT offers in its molecular modeling and computational chemistry product space. With that, let's get into the most important question that you would want to have answered from a company that says is doing something. So if you looked at BioSolveIT from afar, or from whatever distance, the actual question that you would ask is, what does this company want to offer? What does this company operate on? Or what are the core intentions of this company? We've tried to summarize this in a couple of sentences. So round and about, we'd like to provide domain experts with expertly developed software that empowers you to significantly enhance your performance and excel in your work. That seems pretty generic, but when you look at every component of the product, of our product portfolio, you will see for sure that every piece of software has been thought of from the ground up. So goes without saying that we expand the entire length and breadth of computer-aided drug discovery. So from structure and ligand-based discovery solutions, which we will talk about, chemical space navigation. This has been a highlight of ours. We are perhaps without a doubt the industry leaders in chemical space navigation. And where I think that BioSolveIT stands out is in the interactive and fun to use nature of the solutions that we provide. All right, so now if we take a closer look or a much narrow down from the company's point of view, from within internally, we set our goals on this one sentence. We'd like to build the most user-friendly products, and that's an emphasis. That's something that we don't want to compromise on, with scientifically excellent ingredients. And I'll come back to it in the next slide to explain why I emphasize that. That delivers daily value and fun for the user, which means our tools should rather act as companions. I often have the analogy of keys, wallet, phone, and SeeSAR. Is the view that we build our products with, that it should offer daily companionship and fun for the user. And with that, we are proud to say that we have essentially achieved some of our long-standing and rather ambitious goals. We've become the leader, the industry leader in the field of chemical spaces, so namely combinatorial chemical spaces, as Alex very beautifully explained. The burger analogy is something else, I should say. So by being the leader in the industry, we have proudly achieved the following. So first off, we've demystified the complexity of accessing large chemical spaces. In essence, what this means is you do a couple of clicks, download a piece of software, and in another couple of clicks, you're ready to explore trillions of compounds through similarity methods. So demystifying the complexity was one of our core goals and that we've successfully achieved. User-friendly access to multitude of relevant chemical spaces, and I'm pretty sure that the word multitude is sufficient to describe 8 or 9 commercial vendors who offer their spaces within our platform exclusively. So we've also done that really well. And most importantly, provide multiple ways to explore chemical spaces. And I don't have to explain this in as many words because we've seen the talk from Orion Pharma yesterday and the emphasis on why orthogonal methods used simultaneously are necessary to really get the most valuable compound out of a chemical space. So I'm, as a person leading product for the company, I'm happy and proud to say that as a company, we've achieved all of this and strive every moment forward to push the boundaries in this regard. Okay. Now comes the question of what drives us. So let's look at these 2 pictures for a while. So on the one hand, on the left side, we have the typical depiction of a chemist or a medicinal chemist. You see her environment, you see her surrounding, and by this you could also sort of imagine how her day would have started and ended. Maybe this person came in, took her first coffee, put on her lab coat and started looking at her notes for reaction planning, looking at what experiments to design, and went about doing her work in the laboratory. And on the right-hand side, we have a very handsome man with a beautiful smile. Fun fact, he is one of our colleagues, our head of services, Raphael, who gracefully agreed for me to use his photo. And on the right, we have a picture of what one could typically describe as your standard computational chemist. Of course, you would imagine more of a futuristic setup with multiple huge monitors and so on. But the reality is that this is the setup. You have a computer, you have a notebook in front of you, you have some coffee, you have a bottle of water, and you walk in and you spend your day looking at these structures, designing your molecules on the computer. Well, at the end of the day, both these people with extremely different lives, with extremely different motivations, with extremely different day-to-day habits and work protocols, ultimately want to achieve that one same target of designing a beautiful molecule to, in a larger sense, to probably cure a disease or to find a better drug for a disease. Now, all of this boils down to what drives us. And I have this extremely contrarian and controversial opinion that the molecular modeling or computational chemistry industry is the only one in which computational chemistry software is not made for chemists. Also, although it is called computational chemistry software, right? Software always in this domain needs a separate expertise, a learning curve, and a sort of a specialization in the field, which I'm not saying is wrong, to even be able to operate in the space, to be able to collaborate with other chemists in the field. And what drives us essentially is we are trying to answer this question. And although we don't say it explicitly, if you work with our products, and if you talk to our users, and if you are a user of ours, and if you think about it from afar, what drives us is this mission of trying to answer these few questions. Can we build tools that bring the medicinal chemist and the computational chemist look at the same things? Means look at the same problem space, look at the same structures, the same designs, the same hydrogen bonds, and infer things from the same from what they look together at. Speak the same language, which means, yeah, if you are sharing the same seat at the table, seat at the same table, you're also able to speak the same language, and also, of course, design together. We've seen a few examples yesterday in talks where the presenter would say, yeah, we then spoke to our chemists, and then the chemist said this, and we also found that when it comes to synthesis, we were able to synthesize an analog of the molecule much easier than before, and so on and so forth. We want to make sure that this conversation, this collaborative work becomes less isolated, but almost seamless at a certain point of time. And this is somewhat of an utopian vision of our future. And this is the sort of solution space that we are trying to build. I hope that has sort of clarified the fundamental question as to why we've been in existence, and we've striving to build user-friendly products for all of our users. Okay. Now, let's, with that philosophical motivation out of the way, let's actually get to the bare bones of what we have. So our entire portfolio can be split into three major segments or domains. So on the 3D design side, you have the tool SeeSAR and its components. infiniSee and its components comprise the 2D chemical space navigation portfolio. And HPC is our new kid in the block. And HPC is sort of a enabler. So HPC is our high performance computing infrastructure, which takes now components from the SeeSAR family and runs them at scale, either in in-house clusters or in special cases, even on the cloud. So that's also a direction. And down the line, we will also see some components of the chemical space exploration portfolio, so the infiniSee portfolio, also being supported by HPC. That's how it looks. So let's look at some of the components closer, because of course SeeSAR is a massive application. It is segmented into multiple modes, as some of you might know. But the highlights include docking is done by FlexX, and fragment growing is done by the algorithm FastGrow. Conformer generation within the tool, and also as a standalone tool, is done by the conformator. Scoring, one of the most important parts of drug design, is done by our Hyde scoring function. And 3D molecule superposition, so aligning multiple molecules on a reference ligand, is done by the application called FlexS. And on the chemical space exploration side, we have a fuzzy pharmacophore-based search in chemical spaces using F-trees, closed analogs, are provided to you by SpaceLight, and the insane problem of substructure matching in combinatorial spaces has been beautifully solved by the algorithm SpaceMax. Colibri, as you see, is a special tool that enables the generation of a chemical space. So it essentially takes building blocks and reactions in a certain format and then builds out a combinatorial space for you. As I said, how can we bring computational chemists and your medicinal chemists together? Your medicinal chemists have all of the advantages of working on a 3D platform, point and click, look, visualize, appreciate, whereas the number crunchers and the computational chemists have all of these components available as command line tools. And we've seen a beautiful demonstration of that from the Orion Farmers talk yesterday, where they've used F-trees and SpaceLight in conjunction, and they've also spoken widely and deeply about how this is important for their entire workflow. I'd like to point one very important thing, and this defines a fundamental property or characteristic of our company. Every single algorithmic component that gets integrated into any of our tools is peer-reviewed and published. So we make sure that the algorithms have been scientifically validated, peer-reviewed, published, people know how it works, and thereby we don't have to really focus on making every single step within the tool we don't have to break every single step of the tool. So as an example, we can load in a protein, extract the molecule, define the binding site in one go, because the multiple components that work between loading the protein and estimating the affinity of the ligand are all standard and published and peer-reviewed and so on. So if people have a question of what happens, they could always go and read the publication in the worst case. So this is one of our strengths, and I'm proud to say that we will continue in this direction. So anything that we will be scientifically strong and valid, and that ties back into the sort of vision that we have, or the mission that we have, to build the most user-friendly products with scientifically excellent ingredients that delivers daily value and fun for the user. All right, now we have on the desktop modeling side two applications, SeeSAR and infiniSee. SeeSAR is your molecular modeling and editing and docking and ideation software, whereas infiniSee is your platform for mining from trillions. So you put in a query molecule, run a search, and you get your first 100 similar compounds from a chemical space of 1 trillion molecules or even more. Right. Why I keep emphasizing that we design products with the end goal of making chemists, medicinal chemists, and computational chemists work seamlessly together is buried in these three words. So fundamentally, everything that we do within the software must be fast, must be visual. There should be a clear and visual component to it, and must be easy. So we know that people have a lot of things to do in a day, and wanting to sit and learn a new piece of software is not should not be on the priorities of a scientist. Learning a piece of software is good, but there's a certain limit to it. So fast, visual, easy, although you'd only see this on SeeSAR's home screen, is essentially our mantra to develop any of our 3D applications, and also the algorithms that run these applications. SeeSAR per se, or even infiniSee, is segmented into modes, which makes life much more easier in the sense that life is a lot more organized. So you have modes that handle proteins, and operations on proteins. Obviously, you have the protein editor, and the binding site mode. You have modes that exclusively handle molecules. I'm sorry, not exclusively handle, but predominantly work on molecules. So you have the molecule editor, the analyzer, and the inspirator. Each have pretty much the name should speak for itself. The molecule editor should enable you to manually edit molecules and visualize the consequence of these edits in 3D. And we have a separate mode for docking, because within the mode we support 3 variants of docking. So standard non-covalent docking, your template-based docking, which we've also seen in a couple of studies yesterday, and covalent docking. So FlexX has been modified to help you do covalent docking. Of course, one of the big modes in SeeSAR since SeeSAR 14 has been chemical space docking. I would call this as the crown jewel in our product portfolio at the moment. And on the other hand, we have the similarity scanner, which runs FlexS in the background and does 3D alignments of molecules. You'll know in a few minutes that we are slowly but steadily expanding in this space, in the ligand-based space of our portfolio. And that's it. I'm going to focus on 3 pillars of our development motivation and strategy. And the first, and most of this will have SeeSAR as its example. The first is interactive visual assessment. So you can read what this means on the slide, but I'm just going to show you an example or a couple of examples. So we recently, by recently I mean in 2021, had an exclusive paper that ultimately said a lot of decision making in structure-based design is still driven by virtual screening. Is still driven by visual inspection. I'm sorry. This is, I will again say, it's a must read for people to get a deeper insight on why visual inspection is still very important. A second sort of inference to why visual inspection is important came from this very recent paper that we've also seen quoted several times yesterday by the speaker from Orion Pharma on the difficulty to rescore hits from ultra-large screens. And in the conclusion section, there's this very interesting line. So this visual selection is indeed possible and is even recommended, but it requires true expertise from a seasoned computational chemist and a reliably low number of pulses. So this is the problem space. We know that we can screen billions and trillions in reasonable amounts of time, but those final set of 100 to 200 molecules that need to go for synthesis still has to go through a process of, you can do rigorous filterings based on varying levels of complexity. But at the end of the day, visual inspection is a significant component. And SeeSAR, right from its earliest inception, has had visual assessment, especially of the affinity component, as one of its core strengths. Next, compound ideation. So this is where we proudly say that SeeSAR is a chemist's best friend or companion. We have 3 different automated methods. So analoguing that generates medicinal chemistry transformations to improve your compound in the pocket, fragment growing, an incredibly fast algorithm that grows into a selected direction into your pocket. and rescaffolding. And all of these were developed with experts from the academia and industry, where you could select 2 or 3 spots on the molecule and ask the computer to replace the core with other chemically valid suggestions in 3D. And all of this is done in lightning fast speed. Finally, there's a component called augmented discovery. And we could talk about several examples of what augmented discovery means. We have docking, virtual screening, chemical space docking, HPC support. But I'd like to include, what I'd like to show as my example here for augmented discovery is our latest introduction of molecular mechanics. So we've recently introduced force field-based energy minimizations with our partners from Yazara. And this is now available to all SeeSAR users from within the protein editor mode. So you could run your energy minimizations from a variety of different force fields. Your typical Amber family of force fields is available out of the box. The specialty Yazara force fields are available out of the box. And within a couple of clicks, you end up with an energy minimized form of your protein, which you can, protein and your protein ligand complex, which you then take to do other things with. Okay, that was that about SeeSAR. So ultimately, we have a platform that enables interactive visual assessment, compound ideation, and augmented discovery. And that pretty much covers the end-to-end of what visual structure-based discovery should provide. There's a special mention about Hyde, because everybody asks you what is your force field. So first off, we don't have a force field as such. We use a scoring function and called Hyde. So that's hydrogen bonding and dehydration. The highlight of Hyde is it is desolvation aware. So it's one of the only scoring functions out there that carefully considers how desolvation affects the binding of your ligand. Another highlight is, of course, the visual interpretation of scores. And this is where daily value comes into play. People are able to look at the screen and decide what part of the molecule is bad for affinity and what part of the molecule is good for affinity. Right. So now let's look at the other part, infiniSee. infiniSee works, again, on the basis of 3 different modes. But in general, it offers you a gateway to screen trillion-sized compound sets in minutes or seconds if you have a reasonably good computer. And by reasonably good, I mean like a 32-core laptop is reasonably good. The highlight here, again, is that every single result that you retrieve is synthetically accessible. Alex had mentioned this already. And the platform as such offers the power to orthogonally screen compounds, which means you have 3 different methods, or rather 3 different perspectives of looking at the same compound, because depending on the stage or your objective or your current discovery objective, the nature of screening might differ. So at a certain point of time, you only want to find close analogs. So you could therefore then use the analog hunter or spacelight. There could be cases most often where you already have a reasonably active compound, but you want to scaffold hop around the compound, meaning you want to find molecules with similar properties but reasonably different structures, and that's when you use the scaffold hopper or the F-trees algorithm that runs it, and the motive matcher, which runs substructure searching. This again has multiple ways of accessing it. So we have a method to run exact substructure searches. We have a typical MCS-based substructure search, and recently we also introduced the ability to do R-group-based substructure searches, which means you mark a certain part of the molecule with an R as an R group. The rest of the compound is kept undisturbed, and we only search and find molecules that fit the R component of your query. All right, again, the modes are bound to operate where distinct functionality is modularized and isolated within the application. So confusion, obfuscation of results is essentially avoided. I just want to bring this as one highlight that I've seen, and most of us probably know who this gentleman is. The biggest marketing that I personally see so far is in one of his talks, and this is titled "Where the Rubber Hits the Road." Dr. Walters essentially says probably the most significant thing that's happened to my research in the past 5 to 10 years is the advent of libraries like InMinReal for synthesis on demand. And I'm proud to say that all of these offerings come from our website, from our portfolio. So people find enormous value and use from the chemical space offering. Right. Two amazing examples of how people have taken the components of our chemical space navigation components and used it in their own workflows. So most computational chemistry folks should have heard about the Addison platform from MilliporeSigma. Addison uses essentially the space that is built, the assay space that is built by BioSolveIT technology, and the feature trees algorithm, or the F-trees algorithm, that is used within Addison to search this massive assay space, or the sigma outreach space. I don't have to explain this. This was the talk from Orion Pharma yesterday, but I just want to highlight to you one more time that the opportunities or the possibilities to use these chemical space navigation components are endless, or rather, is not restricted to the scope of this platform, infiniSee. With that, I'd also like to highlight that not only commercial vendors, but several big pharma companies which have built their own in-house spaces and are routinely using it. So for anyone who still thinks that this is sort of a niche underground movement for chemical spaces, it is certainly not the case. It's pretty mainstream now. All right, so let's see what else can you do, because I'm going to leave a very bad feeling in a lot of people's minds if I don't address one of the most important topics of the decade: AI and machine learning. How can chemical spaces help you? Can they help you? Absolutely. How? Simply because all AI approaches just need one fundamental thing, and that's like tons and tons of high quality data. Spaces provide them, or the space technology essentially enables access to all of these, the tons and tons of data that we have from the vendors, from your in-house libraries, so on and so forth. And then it's purely up to you on how you use all of this data that is available for you. So again, this depends on how you construct your models and how you stack your models. We yesterday saw a beautiful case of multiple neural nets stacked together, individual predictions from each neural net taken, fed into some sort of a consensus. All of this and more is possible because of the very quick access to a humongous amount of data. All right, so there are, of course, multiple ways to approach this. You could look at the reagent space, the scaffold space, to get purchasable or synthetically accessible compounds. And also move to the 3D world of things. So you could look at compounds that come from your space, from your infiniSee family of tools, run affinity estimations, and then look for individual del-G contributions or You could train your algorithms on interaction frequencies, or as someone mentioned yesterday, or day before yesterday, PLIFs, protein ligand interaction fingerprints, and so on. And then build models with that as the basis. Of course, goes without saying, physiochemical properties are also directly available to feed into your model, because these are standard outputs that we give you. So that's for each compound, there's enough and more features or properties that we write out for your learning algorithms to digest. Most importantly, anything that you come up with is always accessible. And I see that I'm slowly running to the time where we can reach questions. And with that, I'm just ending my talk. We've seen what we as a company and we as a product company want to bring to the community. You've heard about the core motivations of how we develop software. You've seen how user-friendly access to both the 3D and 2D world of ultra-large chemical spaces empowers discovery. My day-to-day role is to be a product manager or product owner, and I also have some insights into what we are building next. So for those who are watching, those who are eager to know the trajectory of our development pipeline, I'm going to give you a small heads up and to probably see where we are going. So the first thing that I'm going to tell you about is this is a screenshot of our mode selector. And for those who've not already noticed it, there's this new mode that is going to pop up. It's called the hotspotter. So what the hotspotter is going to do is help you generate pharmacophore hypotheses from aligned sets of active and inactive molecules. So we already saw yesterday from one of the talks as to how pharmacophore hypotheses actually made the difference in the screening endeavors. So this is going to be a really cool feature. We've seen users whom we've worked with while we developed the feature benefit from it significantly. And so if you're someone in the ligand-based space where you simply have just molecules with active and inactive labels on them, you're going to have a great time. On the other hand, we're going to work we're going to make a few more steps towards balancing out on the protein side of things. So we are actively working on a solution for what people often call as loop modeling. So essentially to build and optimize undersolved segments. So and we are relying on the expertise from Yazara, which is essentially packaged within SeeSAR to build this solution. And finally, we're going to make chemical space docking much faster. And I cannot emphasize on the much, because with some pre-filtering applied to the spaces, docking is going to be exceptionally faster. So what took days for you should take hours in the future with judicious pre-filtering. And finally, a bit long-term, because I also want to put this word out that we are making our first strides to offer molecular dynamics-based support from out of our SeeSAR portfolio of tools. So that's what is to watch out for. And that also brings me to the very end. I'm going to say thanks for being along with us in this talk. Thanks for being customers, users, and we hope to enjoy the ride together in the months and years to come. Thank you.